Okay, so we're discussing question 8, and we're talking about uh, choice of routes. What are the factors that affect the choice that a packet, the choice of routes that a packet chooses? So as we can see, it can either go this way, this writing this way, or once again via true. What are those choices? That answers question number 8. So a lower gateway IP address, definitely a no. A higher gateway, definitely a no. The answer is between A and B. Which one will you choose? Maybe start by defining what a metric is and what is a metric and examples of metrics that we have. Yes, there's someone, a metric. The answer is A. Yes, the answer is A. And what is a metric? Hop count, voila. Maybe start by defining what a metric is. And I think it will make it easier to understand. All right. So basically, a metric, we can define it as the cost of using a route. And the cost of using a route can be determined by a number of factors. So, for example, if it costs a lot to go using path number one, it means packet really won't choose path number one, basically. And if it costs less going via number two, then that's the path that is going to be taken. That cost is determined, for example, by the bandwidth of the link. So can a link iri 1 gig, iri 100 meg. Packet don't choose a link 1 gig because it's faster, capacity yakawanda, less likely to have congestion there. So you see in terms of cost, from a matrix, link giga Ethernet less cost than link 100 megabytes, for example. So metrics are basically costs that are used uh, to choose the best path that can be taken by a packet via a router. Okay, so what we need is a lower metric. A lower metric means a lower cost. A lower cost means that path is much preferable than other paths, basically. Right, let's go to number 9. What are two services provided by the OSI network layer? Performing error detection, question mark, routing packets towards the destination, probably an answer, encapsulating PDUs from the transport layer, probably an answer, placement of frames on the media, no, that's the responsibility of layer 2, collision detection, no, layer 2, error detection, no, error 2 as well. I think I can take B and C. Final one is GM error. For number 9, I'm comfortable with B and C. All the other three that are checkers, I think that's for layer 2. All right, let's go. Within a production network, what is the purpose of configuring a switch with a default gateway? A switch is configured with a virtual interface to begin so that it can be remotely managed, management purposes, and only that. And the reason why there is a default gateway is because if you are managing that switch remotely, then you need a default gateway. That's where our answer is. So it provides an next hop address for all traffic. No. The default gateway is used to forward packets originating from the switch. No packets originate from the switch. A switch must have a default gateway to be accessible. This is a potential answer. Hosts are connected to the switch can no. Hosts that are connected to the switch can use the switch default gateway. No, definitely no. So our answer there is B. Oh. Huh? A switch must have a default gateway to be accessible by Telnet and SSH. The default gateway is used to forward packets originating from the switch to remote networks. Question mark, nga. Let's explain our answers. Packets originating from the switch to remote networks. A switch must have a default gateway to be accessible. Right? What if, more questions there. What if we want to connect to a switch using a local device, also using Telnet and SSH? Will we need a default gateway? Question. At the Bindiano. Right, Lloyd. Let's say we have a local network here, two my PCs. Right, that's a local network.
I think
Can this PC not get access to this via SSH and Telnet, personal default gateway?
inokwanisa ndichinengeta configure IP address paswitch ipapa saka inokwanisa.
Meaning B is not correct.
I think if we B might be the correct answer, because if we want to use Telnet and SSH, we have to create more like actually a VLAN to access the switch and give it an IP address. And once we create a VLAN, it means now that particular VLAN is not associated with any physical port on the switch and is on a different network. And if it's on a different network, then it needs a default gateway for it to communicate with other networks via SSH.
What about PCs that are connected to that switch? Are they in different networks? I just gave you an example, this one. Can you have this PC?
They are not in different networks, but is it different broadcast domains? But for this one, for this answer B to make sense, which is probably the sensible answer here,
And it's not the only sensible answer.
we'll have to tackle it via.
It's not the only sensible answer. But no, one answer, and that's keep up, because in my mind I said a switch does not send packets. But actually, a switch does send packets. Our answer here is C, right? Why I went for C is because if we look at B, we can have a situation where PC is local and can still get access to this without using a default gateway. And the reason why is because it's local. My IP addresses, in terms of my IP addresses, can I want to switch? Let me answer you, but we're going to create a VLAN, which is okay, meaning it will be in a different network or a broadcast domain, as you wanted to say. But ndikaenda router vese vachapfuura nepadefault gateway iri. Kana vese vachapfuura nepadefault gateway iri, it means vese vari in the same network. Are we together, Lo? Do you get that? So it does not.
Yes, I do.
It does not make sense with the virtual interface created up. Are different network from my devices are local or are connected to that same switch. So therefore, he answered it wrong in that sense. In Pandaro Tango is I thought that's the answer, but can I send that locally? Then it's no longer the answer. The reason why ukaona keywords, ukaona pass default gateway, think remote. Think remote. And para B app, we are not talking remote per B app. We can talk local as well. Therefore, that's why it's not the answer. Now let's look at C. The reason why I skip a C in my mind, I was fixed by B, and I was thinking B is correct. But however, local B is no longer correct. But I think C can be an answer. Why? The default gateway is used to forward packets originating from the switch. When we say we create the SVI so that we can manage our switch. When we manage our switch, it means we are communicating with the switch. If we are communicating with the switch, it means we are sending information to the switch, and the switch is sending information to us. So when the switch wants to send management traffic to us, how does it send it? It will need the SVI1, it will need the default gateway if we are on remote networks. Does it make sense?
Yes, it makes sense, but one can also argue with the packets, they don't really originate from the switch,
They do
but from the
originate from the
pieces that are
No.
not the pieces that are connected to.
No. Right. Right. Let's look at this. Let's have Regatise can network here small. Let me find a page. Right. Let's find the network here. Right. Let's have our switch. Let's have our PC. Let's have one PC. Let's have our router. Let's have another PC too. Right. If I want to manage the switch remotely, it means I want to connect to switch Rango using PC2. I want to configure a host name on the switch using PC2. How do I do it? It means I will need to have this switch configured as an SSH client. We'll get there. Yeah, configure as an SSH client. It means now I can configure from PC2. If we talk of the console, there is a console for PC1. Console. Traffic which is being sent between these two devices is being sent from the switch to the PC. Pandana change host name, the traffic over from between the PC and the switch. Pandana change our interface, Pandana sama IP address per switch. Pandana sa switch virtual interface per switch. The traffic over per PC kuenda per switch. Switch will communicate as well. Right. If we are now communicating remotely, we are exchanging, it's the same process. We are exchanging information between these two devices. Am I making sense? It's not only the PC which is sending information. The switch can also send some information to the PC. I can hear the silence.
It's clear on the side now that you have explained, but otherwise, I shared the same sentiments in Na Black Russia.
You
But
share the same
so far,
sentiment.
I think
Put
it's
the piece. Okay,
yeah.
let's do this. Let me do this.
No, I no longer share the same sentiments. Well, I used to share, but then now that it's clear.
Sent by switch. Let me see. Let me get some help. Right. Panapa, the management traffic. Just a minute. Let me management traffic sent by switch to PC. Let's say to PC. Configuring, monitoring, troubleshooting, SNMP. And I wasn't thinking of right, syslog messages. That one is a very good example I can use. Right. Right. Keep that on hold. I wanted to mention the issue here. Right. Can I send the information between a PC and an intermediate device, a switch in this example? There is a console. There is a fast Ethernet. I-traffic yakasiyana hiyo. The reason why it isn't my initial configurations in the fast Ethernet, it is a console. Why? Why do we do that? Why it isn't that? Because data, this fast Ethernet is fast link in the PC in a switch. It's for data. It can be used to communicate with via the switch with other devices in the network, even with the switch itself. But why do we not use the fast Ethernet to configure the switch? To Tinoshansa console. The reason is because today, two different types of data, dzakatosiyana. Management need data information the message that we are trying to send, the user is trying to send. So management traffic is different from that. Now, kana tadzoka to our question, kana tiri kusenda ma-commands kuti change the host name, ari kubva from PC2 achienda kuswitch. Change the IP address, ari kubva from PC2 achienda kuswitch. But pamunochaita ma-configurations, I also want you to test this with packet tracer. You will see, for example, activate the interface. Switch send a message with the interface is up. Mungamboona message iyoyo. Harisi kubva ku-PC. Message yekuti interface is now up. Ma-OS they are now up. Riri kubva kupi message iyoyo? I want Black Russian to answer this one. Where is the message coming from?
From the switch.
Exactly. So message iyoyo kuti ichiende ku-PC uku yakuda chi? Default gateway. Traffic iyoyo ndeye management. Anoti ndo traffic ayo system log, syslog messages. So pane mamwe, for example, I can still remember OSPF. Pachatanga the OSPF. You see kuti a device at intervals will be sending my messages to almost probably every router in the network or every PC in the network. Send them those messages at intervals. Is this device which is communicating in management traffic here? Is it traffic here? My messages are sent between users? No. It's just for management purposes so that my devices, for example, my routers in the network can also communicate, etc., etc. I think this one, going to answer this again. So that's the reason why the answer is C. Pangatarasika isusu one, kuti making an assumption, which switch, I send the information. A switch can send management information, management traffic. Pangatarasika papa. Then assumption ingaitwa ndeyekuti Telnet and SSH doesn't work locally. It works locally. So you will not need a default gateway if it's working locally. Our answer here is C. tinobuda muexam tichiti tari pasi iroro, believe me. Kana magara pasi mada kuita dzimwe nharo, we can always come back. Kutangire ipapo. Yeah, I'm not always right. Believe me. What is the basic characteristic of IP protocol? Connectionless, media dependent? No, it's not media dependent. It's media independent. The reason why it's media independent is because of layer 2. Layer 2 ndiyani inoita kuti IP protocol ive media independent. Right? User data segmentation, reliable end-to-end delivery. Is it reliable? What are the characteristics of the IP protocol anyway? What are the
Connectionless.
Yes, connectionless is correct. What does that mean?
Best effort.
Best effort, voila. You're not the answer. Best effort. Whoa, it's
Yeah,
not
and I was just revising yesterday. Saka.
was really what does connectionless mean? What does it mean?
Connectionless, it means it doesn't notify the receiver of the message that is about to be sent. Apana initial initial communication.
Yeah.
Inoitwa
Like inoitwa ni TCP.
TCP, yes.
TCP inoita that initial connection, right? Okay. Then
So the IP protocol doesn't do the what you call the three-way handshake.
no. You're in the TCP there. The IP protocol it don't go by it. That's why it's not
Okay.
That's why it's not as reliable. That's why this answer is wrong. But can we that reliability? You now work with IP plus TCP. Ukashanda na vari kutuma protocols apa. Ukashanda na L1 is not as reliable. Right, my characteristics are, I think they're very much important. In my head, I'm feeling a bit blank. Best effort, Lloyd and best effort. What does best effort mean?
Best effort inenge inongonobata futi panyaya yekuti it's not reliable. Ndo pane best effort wacho ipapo.
Pane mango, pane imwe ichi 3. Are they not 3?
Imwe yacho ichi media independent.
Yeah, media independent. Right. Best effort. It tries its best to deliver package to their destination, but there is no guarantee of success. Why?
Exactly.
I think lecture I tried to explain why. What's the reason behind having these characteristics? Why is it connectionless? Why is it a best effort? What's the reason? What's the reason behind that? I think I tried to explain that. I remember explaining that.
To reduce my overheads.
Voila, thank you very much. To reduce my overheads. Packets dzinofana kufamba quick networks. So dai raida kuitwa reliable. Raingoiswa mafuse ekuti riti 3-way handshake. Then it will be reliable. But the problem ndeyekuti run a lot of overhead. Kana run a lot of overhead, kuti richifamba network it becomes a problem. So I think nyaya yese is being linked to reducing overhead. The packet, right? So our answer here is A. Let's go. Number 12. Which field in the IPv4 header is used to prevent a packet from traversing a network endlessly? Time to leave. TTL. Definitely that one. Sequence number, layer 4. Acknowledge number, layer 4. Differentiated services. What does this field do? I think if you remove IPv4, what is this? Differentiated services. I think it's QoS. Confirm. Lloyd in the other panel device. I think it deals with QoS.
I read about it, but it was just only that fine print here and getting my italics. I'm forgetting because there was a lot.
Yeah. Keep practicing. Sorry, my mind. Imagine this is just the introduction and you're saying it's a lot. Yeah. Let's move. What is one advantage that the right? I also wanted to ask, IPv6 IPv4 uses TTL to prevent a packet from traversing a network endlessly, being caught up in a loop. IPv6 IPv4 to the TTL. IPv6 we have opening it, voila. Yeah. What is one advantage that the IPv6 simplified header offers over IPv4? Smaller sized header, efficient packet handling. I think this is an advantage. Small sized source and IP is not smaller. Little requirement for processing checksums. Can someone Google my checksums? I'm still a bit curious in my checksums. What is that? What does it do? Someone Google my checksums for me. Let me try to see checksums. Checksums layer 3. Even if I know it is an error detection, I'm still finding that word very new to me. Checksums. Simple form of error detection, value calculated from a block of data, like a packet. The sender calculates the checksum and includes it in the packet. The receiver performs the same calculation on the received end, the received data. If the checksum match, it suggests the data arrived intact. If they don't match, it means there was likely an error. I think we said the same thing about layer 2, but I don't have a CRC value. So I think this is for layer 2. Then for layer 3, there is checksum value. If you can say, is it a value? Yeah, it's a value. It's actually a value. So layer 3, it checksum, but the whole process, it seems, is the same process. On each layer, from the chart, on each layer, the checksum is computed or recomputed whenever a datagram is created or modified. When such a datagram is received, the checksum is verified. Okay, I think it speaks to the same thing. So in summary, what we are saying, error detection at layer 3, it uses the checksum value. At layer 2, it uses the CRC value. But the working principle, values here is the same. Packet value, a checksum value is created based on that packet. You only got each. And I gave an example. Let's say if that value is 1, that value you're going to send already no packet. Parinosvika kuno panoitwa de-encapsulation, packet rinovhurwa. Information yocalculatorwa checksum again. Ikabuda iri 2. Zero is different from ichavhurwa paichaonekwa packet. And that's a problem. Phenomenon is the same. That's how they check for integrity. So I think it sounds like the same thing for layer 2 and layer 3. The only difference, they would checksum in layer 3, CRC in layer 2. So for this one, number 13, efficient packet handling. Explain that. Can someone explain why? How is that an advantage? What is one advantage that the IPv6 simplified header offers Explain efficient packet handling. Where does it come from? How do we get efficient packet handling? Because of the simplified header of the IPv6. So this one answer is it's curious. Why? Explain that, not why. Explain efficient. Where does the efficiency come from?
I think kuti the IPv6 header harisina mamwe mafields akawanda wanda unlike anga ari paIPv4.
Yeah, it makes sense. Less overhead. It makes sense. So with less overhead, it means efficient packet handling, much faster, less overhead. That's the reason why IPv4 is in a reliability and all those things. In a packet handling. Regarding overhead, it becomes very difficult to transmit over the network. At 14, we get to 15, I think we can. What IPv4 had a few details, field identifies the upper layer protocol carried in the packets. Is it not the version? It's not this one. Identification, protocol. I think it should be between A and C version. IPv4 version. I cannot see version. Protocol is there. Which one is the answer there? Version. The upper layer protocol. Upper version in the IPv4-ish. IPv4 or IPv6. So this one is wrong because it's not the upper layer. I've eliminated, I think that's the answer. Upper layer protocol carried. I think so. What is the IPv4 header fields? What IPv4 header field identifies the upper layer protocol, right? I think it's A. But I'm going to answer. These ones are definitely not answers. B and D out. Then C version. I know we have two more versions, mainly version 4 and version 6. So that leaves answer A. But once my questions, we found out what changam bebe. Kutsokoloza mvunzo. Kutsokoloza ma-answer kusika sure. Kuti yeah, ndizo. Because if you don't do that, my answer, they look very similar. I think there was someone who said it in one of our lectures, one of our sessions. They look very much similar. Right, let's look at 15, probably our last question. Refer to the exhibits, match the packets with their destination IP address to the exiting interfaces on the router. Okay, what do they want here? Yeah, packets with the destination. B, I'm not getting how we get the answer here. But I want to get some from zero. Number 15, let me zoom in a bit. Okay. Okay. Got 4 bits. So this question, match the packets with their destination. And this is mvunzo ngati by 3 minutes. Yanzana bado twarudi hapo.
Kana inini ndiri kufunga kuti panofanira pane another illustration. Maybe that's the only way yatokwanisa kuona kuti aufa. Because there should be an illustration yeka network topology or something.
Oh. So I refer to the exhibit, match the packets, match the packets with their destination IP So fast Ethernet 1 is right here. Your match not all time.
I think that there has to be another illustration you're missing up, I say.
Okay, question mark for number 15. I know in Swiss as usual. I didn't get number 15. Let's move to number 16. And 16, we still have some time. 16, what information does the loopback test provide? A, correct. The TCP/IP stack on the device is working correctly. The device has end-to-end connectivity. No. TCP, no. Ethernet, no. Answer is A. Answer is A on this one. Number 17, what routing table entry has a next hop address associated with the destination network? Next hop, directly connected. Now, let's stop there. I think our time is up. We'll continue tomorrow to pages of this one. Starting up at number 17. I think a good job.